Right. Good day to everybody watching. I'm not sure what time of day this presentation is going to catch you, so I'm not going to stick to a specific time. My name is Anjali Yancy. I am a solutions engineer at Aligned Automation and a soon-to-be MTech student at National University of Singapore. And my co-collaborators on this project are Dr. Subikshan, who is the Assistant Professor of Orthopedics at SIMAS Chennai, and Dr. Monisha Madhumita, who is the Assistant Professor of Dermatology at SIMAS Chennai. At the outset, I'd like to thank the organizers for creating this inclusive and accessible conference for all of us to learn, collaborate, and grow. And I would like to do my fair share through our presentation, revealing insights, forecasting demand, visualizing data for optimal dermatology clinic operations, and a little pun on the R. So coming to the presentation of today, I have a little story for all of us. So growing up, I had quite the case of severe dermatitis, had extreme dry skin. So my childhood had a lot of dermatology appointments. And there were two different types of doctors. One whom I'd had to wait forever for, but the appointment itself was super quick and extremely efficient. And the other one who would spend a lot of time with me, but at the same time, the nature of the appointment itself did leave me with a lot of questions at the end of it. And I wanted the perfect blend, someone who would be there on time, but at the same time, someone who would help me get my questions clarified and not leave me feeling overwhelmed or confused after the appointment. And this was the mental background that I had before we delved into this particular problem statement. Now, coming to the problem statement itself, I am from India, a particularly populous nation. And what that means in terms of healthcare is the doctor to patient ratio is always rife with disparity. There is one doctor for every 130,000 patients. So what does this mean? This means that there is always going to be more patients than there are doctors, which means there's going to be chronic overbooking and understaffing. To tackle this, we explored it through the use of data-driven decision-making in healthcare. We just looked at it as a problem of demand forecasting. And the outcome that we were hoping to achieve was improve patient satisfaction. Now with this, let's look at our agenda. We've introduced the problem. Now let's look at the key data points, the methodology, results, and future steps. Now, the key data points themselves. Our objective was to understand the frequency and nature of appointments in the associated clinics and understand the impact of external factors such as weather, local events, and public health data. So the data that we captured was the appointment data, the clinic data, environmental metrics, such as the pollution level and the weather, and local events and public health data. And if we were to look at it in terms of the problem statement itself, we looked at it in southern India, which is the region that I am from, and we looked at it in the context of dermatology practitioners. Now let's move to the methodology. What we did was we collected the data of patient history from 10 clinics. And this was collected over a period of 24 months, which is sufficient enough to capture seasonality, trend, and any cyclicity that the data may have. And we passed the data through the data analytics pipeline. And this was done with the support of the programming language R. Now coming to the methodology itself, we prepared our data and cleaned it up using the diverse ecosystem. And because this is ultimately a time series problem statement, wherein we look at the case history as a factor of time, we tested out time series models such as ARIMA and Facebook Profit for demand forecasting. And we also applied a regression model because we used other multiple variables as well to identify the relationship between our patient volume and the case types. And since our primary stakeholders who are going to consume this and our collaborators were doctors, we needed clear, informative, and interactive visualizations, which we achieved using the famous Grammar of Graphics ggplot tool and improved its interactivity with Plotly. And with this data in mind, the next thing was to do scenario testing. which is to say if we had a certain amount of resource allocation, what would our case load look like and things like that. And we did this with sliders for staffing. Now, this was further made interactive using the Shiny app that integrated all of these features, and we brought it to a user-friendly front end. Now, if we were to look at the data analytics pipeline itself, for those of us who are here, we start by collecting the data of all of the relevant sources, such as our appointment data, environmental data, and public health data. And all of this is in silos. They're just tables that are collected and are relevant. Now we have to integrate them together because it is a unified source that we're consuming. And this was done in the data integration stage. Following this, we transformed the data through cleaning methods and only considered their relevant features because cases were considered as case ID. But now that case ID itself holds no value, we needed its unique count. And following this, now that the data itself was ready, it was ready to be cooked, the cooking translates to machine learning. We did that using a combination of time series models that we validated using 30% of our source data. Now, if we were to look at an example of the data, this is case data of Clinic 10, wherein you can see this case data as a factor of time. And you can see that it is relatively stationary, and thus it was the right fit for a certain model known as a REMA. And with this hopeful agenda in mind, we move to our result section, which did not disappoint. If we were to look at overbooking instances, they fell by 30%. Now, this was not uniform or across the board. Some clinics performed better than the others. Now, if we were to look at over and underutilization, this in itself improved by 25%, wherein clinics that had higher instances of overutilization found that post-ML there was a reduction, and those with underutilization, that is instances wherein there were too many staff and not as many required to be hands-on, that reduced as well. And now let's look at it from the perspective of the patients themselves. Their wait time reduced drastically or fairly well over the 6 months post the implementation of our machine learning approach. And when we looked at their patient satisfaction through the Net Promoter Score, there was also an increase in that post the integration of our machine learning approach. Our future steps is to improve the interaction capability of the platform to make it more user-friendly and easy for the doctors and other stakeholders to utilize. Now that this was done using a test scenario only, our aim and future direction would be to deploy it for permanent use and make it usable with real-time data. If there are any questions, we would love to hear them. This is my QR code and my email ID, as well as phone number. You can scan it and we can stay in touch. We are particularly happy to have collaborated with this amazing conference, and I would love to learn a lot more from your questions. So let's keep in touch. Thank you.